Hi everyone, in this video, I would like to discuss subtopic 6.2. So 6.2 is about equilibrium of a uniform rigid body. First, the objective of this topic is you need to be able to state the physical meaning of cross vector. This is the cross vector, RF. And then define and apply torque, state the condition for equilibrium, and solve problem related to equilibrium of rigid body. Okay, so if you guys still remember, previously I shown you the relation between S, V, and A from linear equation with the rotational. So for S, you have something similar in rotational, which is what we call theta. For V velocity, we have angular velocity, omega. So theta is angular displacement and omega is angular velocity. And then we also have angular acceleration, which is alpha. Okay. And then for force, we have something that is very similar in terms of rotational motion, which is what we call torque. It's not the same, but it's similar. Okay. And then if you have linear mass, rotational, you also have something similar that with mass. This is what we call moment of inertia, I. Okay, we'll focus more on I on the next subtopic, 6.3. And then lastly, we have momentum. Linear momentum, we use P. Rotational momentum, we use L. The symbol that we use is L. Okay, and the last one, the rotational momentum, we focus in 6.4. So the last subtopic lah. Okay, so for today, we focus on this. So previously, we already discussed this one. This video, we focus on this. And then after that, we continue with I and L in the next video. Okay, by definition, torque actually means a tendency of a force to rotate object about an axis. So this one is involving a force that trying to rotate an object about an axis. Okay, this actually one of the definition from the actually I think they is written 3 definition over there, so I just choose one. So in terms of formula, torque is actually equals to R cross F. So this is actually a cross product. Cross product means it will produce a vector quantity. So compared with the dot product like work, okay, work is equals to F dot S. So the resultant of the dot product would be scalar quantity, but this one will be vector quantity. And R cross F means that this one becomes RF sine theta. Okay, because it is a cross product, so it's a component that is perpendicular, so you have to use sine instead of cos in dot product. So this is the formula that you're going to use. R here represent the distance between the force and the point of rotation. So point of rotation is very important. So there is where the position of the axis. And then force applied is F, and theta is actually equals to angle between F and R. So if I just take one simple example like this, so you can imagine that this one is like doorknob. Okay, and then you try to turn doorknob by pulling or pushing the doorknob downwards, like that. So the point of rotation in this diagram, it will be obviously it will be over there. And as this is moving, you can imagine that the force being applied in that direction downwards. So the distance between the point of rotation and force is basically your R. And the angle between R and F is this one. Okay, you can imagine that this is the point of rotation going to the force. So R in that direction, F in that direction. If I make it a little bit longer, then you can see that it's 90 degrees angle between R and F. So these are one of the simple examples on how to use this formula based on this diagram. And then torque, because it has a direction, obviously it has a positive and negative. So if force, if you want to determine whether force is positive or negative, simply force to the right and force upward is positive, force to the left and force downward is negative. And similar to the torque, we have force clockwise and anti-clockwise. Okay, so actually the force that making the object moving anti-clockwise is actually positive, but the force that trying to make, the torque that trying to make the object moving clockwise is negative. So that one actually comes from the right hand rule. So even if you don't know how to use this one, you can simply memorize this one. So if you want to use this right hand rule, you try to see the object tendency to rotate in which direction. So if I goes back over here, if the force being applied in this direction, obviously the object will try to move, try to change my pen color, it try to move in this kind of rotation. This is the direction of the torque, right? So I mean, if you apply this force, obviously the object try to rotate in that direction. Okay, so what you're gonna do is that you're gonna use right hand rule, and because it is in that direction, so I'm gonna choose that one. And obviously you have to put it towards this direction. So you can see that my fingers is actually towards this direction as well, curling toward the same direction. So my thumb is pointing into the page, right? And then you can see that this one is into the page. So because my thumb is pointing into the page, it will be negative, like this one. Okay, thumb pointing to the page, thumb pointing outwards. Again, if you're not sure how to use this one, it's okay, you can just simply memorize. I just want to show you how they got the positive and the negative values there. Okay, so if the thumb pointing into the page, it will be negative. If the thumb is pointing out of the page, it will be positive. So example, maybe one of your friend try to pull one of your friend apply one more force in that direction. So F2 in this regard will tend to move this object in that direction. So because of that, if you want to apply right hand rule, or you simply want to apply that this makes a anti-clockwise motion, so this one produce a positive torque. Okay, so this one will be negative torque and that one will be produce positive torque. Okay, hope that explain. Okay, so obviously if you guys still remember, if you are talking about summation of F force, at one point we are talking about equilibrium of an object. Okay, where as a result, basically we are talking about an object that is at equilibrium. So, and as a result, if you guys still remember, it produces a summation of F equals to 0. So object at equilibrium acceleration is equals to 0. Okay, it does not undergo an acceleration. So A becomes 0. So we have this relation. Okay, so similarly for torque, we have condition for equilibrium. Okay, again the rigid body is simply because the body is rigid. Okay, I mean it doesn't change in shape. Okay, so if you are focusing on equilibrium parts, and obviously if an object is at equilibrium, it has to obey these conditions. Number one, in terms of linear. So if an object is at equilibrium, example, maybe you can imagine that I have a plank, okay, and then I put two boxes on at each end, and then this one is at equilibrium, means that it doesn't move. So it balance. Okay, so if it is balanced, first of all, the linear part should be equilibrium. Okay, and then the rotational part also have to be at equilibrium. Okay, because these two are at equilibrium, will produce this one. Summation of f equals to 0, summation of torque equals to 0. So basically it's very similar to topic force, okay, in a way that summation of f, which you can write as summation of fx, summation of fy equals to 0. Okay, the only difference is that now you also have summation of torque equals to 0. And remember, torque for each component is equals to rf sine theta. For each force, it is rf sine theta. Okay, so in this case, okay, I think I'm going to show you the free body diagram part later. So for now, I just want you to know the condition for equilibrium. So that means if an object is at equilibrium, it has to obey these two conditions: linear equilibrium and rotational equilibrium. As a result, you can write down 3 equations straight away. Okay. So if you go through the lecture notes, it has steps on how to problem solve problem regarding the equilibrium of rigid body. So first of all, you have to draw the free body diagram. Okay, I'm going to show you soon after this. And then after that, you have to pick a point as a rotation point. So the keyword here is actually pick any point, and I'm going to explain more later. And then apply summation of torque equals to 0. Okay, choose convenient x and y axis and resolve force acting into their x and y component, and then apply fx and fy equals to 0. So normally 3 and 5 I would straight away apply together at the same time. So like I did in previously in topic force, I put summation of fx and summation of fy side by side, and in this chapter normally I will put summation of torque side by side as well. Okay, and let's solve equation 3 and 5 to determine the unknowns. Okay, depends on the questions. What are the unknowns that they ask? Okay, example. So this one is very similar to the previous one that I show you. Okay, let's say this example, this system, this object is at equilibrium. So if you want to draw, if you are going through this step, you have to draw the free body diagram first. If you want to draw the free body diagram first, obviously, if you want to draw the free body diagram, obviously you have to identify all the forces acting on this object. Okay, in this example, the object here is actually the plank. You're talking about the plank. So forces that acting on this plank, there are a few types of force. Okay, number one, if you have an object, you should have the weight. Okay, so this object is the plank. So the plank actually has a weight as well. So the first force is the weight of the plank. Okay, because we are talking about the weight of the plank, the position of the weight should be in the middle of the plank. Okay, and you can see that there are two masses on each side of the plank. So let's say I put this one as M1 and this one as M2, and obviously these two will produce a force acting on the plank, which is downwards. So here the weight is pointing downwards, and this one we also have the weight that is pointing downwards as well. But weight 1 corresponds to object 1, weight 2 corresponds to object 2. Okay, so you can see that this one, all the three forces are are pointing downwards. So the diagram seems that it is not balanced. It needs some force that is actually pointing upwards. So that force is actually the normal force. Okay, normally student common mistake, they will try to put normal force upwards in the middle here, but you have to go back to the definition of normal force, which is actually reaction force on the surface. So the only surface that this plank is touching is actually this tip of the triangle here. So the reaction force or the normal force N is actually over here. So it's not, it doesn't have to be in the middle. It depends on the point of the point that is touching the surface. Okay, this is common mistake number one. Student will try to put N towards the middle, which is wrong. So it depends on this position. Common mistake number two, student forget to include the weight of the plank. So be careful on these two. Okay. And then because this one is at equilibrium, obviously summation of F will be equals to 0. A equals to 0, right? And at the same time, summation of torque will be equals to 0 as well. Okay. So after you identify all the forces, you have to draw the free body diagram. Okay. So if this one is not equals to 0, you have to indicate the direction of A and alpha. Alpha is a rotational acceleration. But because this one is equal to 0, we just have to indicate the forces only. So the body here is the plank. So obviously you can draw the body. I mean, it need to have a body lah. It's not a point. Okay, you can draw a line like that, or you can make a square like this one. I mean, not square, rectangle. Okay, so this is your body. Weight of the plank is in the middle here. So even though the names of the diagram is free body diagram, you still have to draw the main diagram. I mean the body. Normal force somewhere over here. Weight 1 in that direction over there. Weight 2 is over there. Okay. So if you go through the steps previously, pick any point as a point of rotation and label the distance r. So basically you want to find the point of rotation. So again, common mistake number 2, students straight away choose this one because by logic this one is not moving. If it is moving, then this one is not moving. But actually the keyword there is any point. So you basically can choose this one, this one, this one, this one as the center of rotation because this object is not rotating. It's at equilibrium. So if an object is at equilibrium, you can pick any point. So where should you choose the point? You have to focus on, normally this is a like hidden rule. If you want to choose a point, you choose a point that with the least amount of information given. So you can imagine they will give you the mass M1 and M2, and most likely they will give you the mass of the plank itself as well. So the unknowns here would be the normal here, because you don't have those value. So if you don't have those value, you're gonna put the point of rotation over here. Okay, some books call this rotation. Some book call this as a pivot point. The same meanings. Okay, but I'm gonna use point of rotation for this chapter. Okay, so I repeat. So you choose to put the point of rotation at the point where you have the least information. Okay, by logic, most likely it is over here. So accidentally it is actually on, I mean at this point lah. But it depends on the question. If they give you n, okay, but they didn't give you the mass of the plank, they want you to find mass of the plank. So obviously you're gonna put the unknowns somewhere else. I mean, because you have values of n, you can put the point of rotation somewhere else. And then normally we don't put it on the one that we want to find. Okay, if you want to find weight 2, normally we didn't put pivot point or point of rotation over there. Okay, so if you want to choose, main thing is that put it on the least information. Okay, I think if you have a question, then you can see it more clearly. Okay, after that you have to label all the R. R is the distance from point of the rotation to the force. So obviously it depends on your point of rotation. If you choose a different point of rotation, you have a different values of R. You just have to follow, doesn't matter. So example over here, for WP, the R is this distance here. Okay. For W2, the R is this distance over here. And W1 is the distance over here. Okay. And you can see that the R for N, sorry, I put this one. It should be R W1. Okay. And you can see that the distance from of N from the point of rotation is actually equals to 0. Okay, why this is very important, why do you want to put it on the list info points? Because if you can still remember, torque is equals to RF sine theta. Okay, so basically if you put the point of rotation over here, so basically if I want to substitute torque equals to Rn sine theta, the R here will be equals to 0. So the whole thing over here is 0. So the normal force does not produce torque based on your diagram because it is sitting on the point of rotation. But you make it to sit on the point of rotation because you choose this position over here. Okay, let's try to look at one of the examples. One of the question in tutorial question. This one is question 10a. Okay, so a rod of mass 2 kg and 1 meter long is pivoted at point P as shown in figure 6.1. A load of mass 6 kg is suspended at one end, and the load of mass M is suspended at Q. If the system is in equilibrium, so the keyword here is in equilibrium, determine the values of M. So equilibrium means summation of F equals to 0, which you can write Fx equals to 0, Fy equals to 0, and summation of torque equals to 0, because this one is at equilibrium. Okay, it means that this object is not moving, it's balanced. Okay, and then if you notice one more thing is that when they try to put the weight, okay, they hang it by a string, so you can determine the position of force straight away over there. If you notice from my previous diagram, I actually put a box. Okay, so that one is actually should be in the middle of the box instead, but this one is more accurate point of the force. Okay, now back to this question. You want to draw the free body diagram. Okay, the question actually want you to find the values of M. Okay, this one is unknown, so you want to draw the free body diagram. But if you want to draw the free body diagram, first of all you have to identify all the forces on this diagram. Okay, so number one force on this body, our body is the plank itself. Force acting on the plank, number one is the weight of the 6 kg. I put this one as M1, so I'm gonna put this one as W1. Okay, and I'm gonna put this one as W2. This one is M2. Okay, and then obviously you still have the weight of the plank. Don't forget, it is right in the middle of the plank. This is the plank, right in the middle is somewhere over there. Okay, don't forget weight of the plank. And then one more force, which is the normal force, and the normal force is the force, the position would be the point where it contacts a surface, which is at the point P here. Okay, now you want to draw the free body diagram. Again, you can draw a straight line, but I want to draw this one similar to the plank. Okay, so just redraw all the forces on this plank. Weight 1, normal somewhere over here, weight plank sorry, just one is weight 1. Weight plank is right in the middle of the plank, and weight 2 is slightly to the right of the weight plank. Okay. Given that the rod of mass, the rod has a mass. Okay, so this one is rod. I call this one plank. So I don't want to change the label. Instead, I'll just say that this one is a plank. Same meaning. Okay, the rod of a mass 2 kilograms. So mass P equals to 2 kilogram, and the length is 1 meter. This one length is 1 meter. Okay, and then after that, once you draw the free body diagram, you want to determine the point of rotation. Okay, so like I told you before, choose a point of rotation where you have the least information. Okay, you do have the values of M1, so you have information over here. You want to find the information on W2. You don't have the values of N. You do have the mass P. Okay, so obviously it's suggested not to put over here or over here. Don't put here or there. Okay, because you have these two information. So the two unknowns are there and there. Okay, and the second rules is that don't put on the one that you want to find. So because you want to find mass 2, you don't put the point of rotation over there. Okay, so you put over here instead. So accidentally, this is at the point of the pivot point. Okay, but it doesn't have to be here. You can change it the point, but it depends, because this question want you to find this one, and you do have these two information, so you left with this one as your unknown. So you put there so that the torque on the normal force will be 0. Torque for the normal force will be 0. Okay, so if the system in equilibrium, determine the values of M. Okay, like I told before, you want to use these 3 information straight away, and normally I'm going to do it side by side. Okay, there's no force in X component, no left and right force, so we just focus on this one. Okay, summation of Fy equals to 0, and summation of torque equals to 0. Okay, the force that are in Y component, you will have N positive because that one is going upwards, and then minus with the negative one, WP, W1, WP, W2 equals to 0. Okay. Okay, I'm running out of space, so I just change the position to there. Okay, on the other hand, if you want to determine the torque, obviously you have to determine the R first. So actually, you have to determine R before you write down the equation. So we have RP over there. Sorry, R2 is actually from the point of rotation to the weight 2, and R1 is from the force to the point of rotation. Okay, so I just want to write, because I cannot write over there, it's too small. Okay, so R1 is 20 centimeter based on the diagram here, or 0.2 meter. I change to meters away. R2 is basically the distance here. Okay, you do have the distance over here, which is 30, and this one is 20. So this is 30, this is 20. The whole length here is equals to 1 meter, which is 100. So 100 divided 100 minus 20 and 30, this one is 50 centimeter, or equivalent to 0.5 meter. Okay, WP is right in the middle. So the whole length is 100 centimeter. Half of it, which is here, is equivalent to 50 centimeter. Minus with that one, 20 centimeter. This part is 30, this length. So this one is 0.3 meter. And R for N is equal to 0. Okay, now, once you did that, you have to determine which torque is positive and which torque is negative. Okay, so if it is anti-clockwise is positive, clockwise is negative. So based on the point of rotation, you have to figure out this force will try to pull this object in this direction, right? So it's trying to make a clockwise rotation. Okay, you can use right hand grip rule to determine, or you can memorize. Clockwise means the torque is negative. And for this one, try to move in this rotation as well. So this torque is negative as well. So just change to torque 2. Okay, and then for this one, torque 1, you can see that it's trying to make this rotation. The force trying to make this kind of rotation. So you can imagine that if weight 1 is unbalanced, it's bigger, so this object will move in this direction. So because of that, the torque here is positive. Okay. So now I can write it down over here. We have 3 torques. Torque for n is equals to 0, so you don't have to write down that one. You can write it down, but you don't have to. And this one is torque 1 and torque 1 is positive, minus torque P minus torque 2 equals to 0. Okay, torque, we use a symbol tau. Okay, so these are the 2 equations that you can write down straight away. And the question want to find the values for m. Okay, because we are running out of space, I just copy this one to the new page. Okay. So if you want to solve, you have an option. So you can solve using this one, or you can solve using this one. Okay, I think the question is pretty simple, and straight away you can see that if you want to solve, using these equations, this equation, you don't have the values for n. You want to find values for, I check back, W2, right? So you want to find M2, which is inside this term. So basically you have 2 unknowns over here, but you only have 1 equation. So if you want to solve it straight away, most likely you have to solve this equation using this equation. So I'm going to bring this equation to the side, and I'm going to put this one on the left. Okay, so that one is just some logical thinking. Okay, so if you guys still remember, torque is equals to RF sine theta. Okay, so if you have 3 torque over here, basically you have to write 3 times. RF sine theta minus RF sine theta minus RF sine theta equals to 0. But each one of these represent a different F, right? Different force. Like for example, torque 1 comes from the weight 1 force, like this one. Okay, torque 1 comes from weight 1. So I'm gonna put weight 1 over here. Torque 2 comes from this one is plank, so weight of the plank, weight of the second mass. Okay, similarly R, it will be R1, RP, and R2. Okay, now sine theta. Theta here represent the angle between R and W. So R vector is from the point of rotation to the force. You can see that if you are talking about weight 2, the R would be in this direction. Okay, the weight is in that direction, so the angle is 90 degrees. Similarly, for weight of the plank, for torque of the plank, R is in that direction, weight in that direction, so it is 90 degrees as well. And on this side, R towards the force is in that direction, force in that direction, so angle is 90 degrees as well. So these 3 represent sine 90, and sine 90 is equals to 1. Okay, so R1 is 0.2. I don't want to skip any steps, so I just write down this one as M1G. So weight is equals to mg, right? Minus RP is equals to 0.3. Mass of P G minus R2 is equal to 0.5. Mass of 2, G equals to 0. So you want to find mass of 2. Okay, so for each one of these, you have a G. You can cancel out by dividing all with G. So mass 1 is equal to 6 kilogram and 2 kilogram for P. So 6 and 2. So I can bring the last term to the right hand side, so it becomes something like this. Just bring it over here. Okay. Now 0.2 times 6 is basically 1.2. Just double check. That's 1.2 minus 0.6 equals to 0.5 m2. 1.2 minus 0.6 is equal to 0.6. So that one would be 1.2. I just double check using calculator. Yes, mass 2 is equals to 1.2 kilogram. So this is the answer. Now obviously this one is actually a simple question, but to solve I just show you the whole step-by-step method, so it seems like a little bit long, but it's actually you can do it very quick once you get used to it. Okay, remember, identify all the forces acting on this body. This is our body. Draw the free body diagram, determine the point of rotation, determine the R. Okay, and then you can write down these equations. You apply the equilibrium. Okay, so you can see that because you want to find mass, you just have to focus on this one. Okay, sometimes you have to do both at the same time, but in this example we just have to focus on this, so you can straight away find the answer.